Hey you guys, Miss Stock here. I'm going to do what I would call a quick triangles review. So if I'm going too quickly, I do apologize, but what I want you guys to remember is that the reason why this is quick is because it should have been something you learned in like 5th, 6th, and then 7th grade. At the very end, I will finally turn our information into what we consider 8th grade triangle information. So, make sure you have your notes ready. We're going to go ahead and get started. So on your Cami sheet, or if you printed it, you should have 3 blanks just like mine. And I'm just going to quickly talk about the different types of triangles. So if a triangle has 3 acute angles, and remember acute angles are what we consider to be less than 90 degrees. So if all 3 of them are less than 90, that's what we call an acute triangle. If the triangles have one obtuse, so again, let's make a quick note on that. Obtuse is greater than 90 degrees. So if one of those angles inside of the triangle is really big, that's what we're going to call an obtuse triangle. And then if one of the angles is a right angle, and that means it equals 90 degrees, then that's what we considered a right angle triangle. Just to make another note for you guys, the right triangle would have a box in the corner. We really talked about that a lot in 7th grade. All right, so now we're going to just talk about quickly the sides of the triangle. So this is the outside, like what this little guy is stepping on. So we've moved from the inside to now the outside of the triangle. So if all sides are different, meaning they're not congruent, that's a scalene triangle. If at least 2 of the triangle sides are the same, that's what we call isosceles. And normally it's like this one and this one. And normally it's the bottom one that's different. So 2 of the sides are the same. And then if all 3 are the same, which is kind of what you have here, all 3 sides are equal, that's what we call an equilateral triangle. We won't be talking a lot about this today. We're mainly going to focus on the inside, which is the angles. All right, so just so you guys are aware, this is a triangle that has 3 already marked angles inside, 55, 65, and 60. And you should remember from 7th grade that if you take all 3 angles and add them up, they should always equal 180. That's what we kind of call our magic number, so I'm going to highlight that. So you need to write that down and then maybe even circle it, star it, highlight it, whatever you have on your Cami to use, but they will always equal 180 degrees when you add them up. All right, so on yours, it's just a bunch of lines. There's no numbers. So I'm going to go ahead and show you what those lines mean. So the inside angles are what we call the interior angles, and I'll highlight that for us. This is interior or inside. And then the other ones that are there, those are what we call the exterior angles or the outside angles, the exterior. Okay, so this triangle, although, you know, it's right here in the middle, it has these lines that are coming off of it. And so that's kind of more of a 7th, 8th grade example of what we'll be talking about in a minute, but you'll have both interior and exterior angles to worry about. So inside and outside. I also want you to realize, and I'm going to draw a picture with this. I'd like for you to kind of fit this somewhere on your screen as well. So, like, let's just say we have a quick triangle with an extra line hanging out. So I've got my interior angles, and then I've got an exterior angle, and that might be something that we can highlight. So this is our exterior angle. And then my interior angle is on the inside. If you add these up, it also equals our magic number, which is 180 degrees. There's our magic number again, 180 degrees. So real quickly, let's do just a kind of a quick stop and review. If you add up all three of the inside angles, it equals 180. But if you also take one of these interior angles and add it to the exterior angle that's right beside it, they will also equal 180 degrees. That magic number shows up over and over again with our triangles. All right, so this is the part where we're going to do some practice. It starts off kind of easy, more 7th grade-ish, and then it'll get a little harder as we go. So we've got this 90-degree angle right here, and I know that it's 90 degrees because we said it would have a box. I said that earlier. We have a 55, and then, or I'm sorry, a 51, and then we have an unknown, or what they're calling X. So if you remember from earlier, if I add up all of my angles, they should always equal 180 degrees. So I've got to figure out what this unknown would be. There's several ways to do this. You can take 180 degrees. Some kids do it like this. They take 180 degrees and they work backwards. They subtract the 51, and then they subtract the 90. And then at the very end, you'll get what you're left with. Some kids do it another way, and it's really up to you how you want to do this. You probably figured out the way last year because you did this last year. Some other kids will take the two that they know, add those up, and then subtract that from 180. So that would be 141. And if you subtract that from 180, what do you guys know that you get? Right, you get 39. There's also a very algebraic way of doing this, but it just kind of turns into more or less one of the steps that we've already done. All right, so let's move on to number 2. Remember, you can always pause it if you need to rehear what I just said. So for number 2, I've got 66 listed, but nothing else. So I know that the bottom 2 are unknowns. So I know that I have 2 unknowns and the 66, and that they all together should equal 180 degrees. So you could work backwards like I talked about earlier, and you could take your 180 and work backwards and subtract off the 66. Now, this is the part where you really want to make sure you have a calculator in front of you because you don't want to make sure you want to make sure that your mental math isn't wrong. But it is 114. But guys, that doesn't mean that this X is 114 because this is a teeny tiny like little acute angle. What it means is that 114 is what's left over, and I need to split it between these two X's, which really means I just need to cut it in half or divide it by 2. So that divided by 2 would give me, anybody figure that out yet? It would give me 57. So I know, and it just popped up right here, I know that this is 57 and that this one is also, right here is also 57. I think this one is worth showing the algebra for. I know that one of the IXL ones will come up like this, so I am going to work it through algebraically. So real quickly, I know that these two X's can also be written as 2X, and then plus the 66, and then it equals 180 still. So in algebra, you should have learned that the first thing to do is to subtract the 66, and that would leave you with 114, and you just had that. But you also still have the 2x that you haven't done anything with. So you've got to bring that down and set it equal to 114. and then you would divide off the 2, and you would get the 57. Same answer we just got right here. So you can do it the more common sense way, just using your calculator, or you can do it the algebraic way. Either way is fine. You just have to pick and see which one works best for you. All right, so this is kind of like the example I gave earlier where we have an interior angle and it's sitting right next to an exterior angle. And we said that interior angles, and we'll call this X because we don't know what it is, plus our interior angles are also supposed to equal 180. So this, you can just go ahead and solve this algebraically if you would like. Or you may have said, well, of course, I'm just subtracting. I'm working backwards. And if you have figured that out, it should be 132, I believe. Yep, 132. I'm going to erase that so you can better see it, 132. So again, we just took our interior angle that's sitting right next to the exterior angle. They have to be sitting right next to each other. And we just subtracted it from 180, our magic number. All right, now this is where we're getting to be more 8th grade about our work. So example 4, and I'm going to circle it. Maybe I'll circle it, maybe I won't. Example 4 is where we start to get real 8th grade-ish. There's a formula that you guys are going to need to write down. Okay, so the name of this theorem is called the exterior. So I'm going to write it up here. Grab my pen. Exterior, my pen doesn't want to work, does it, guys? Sorry about that. Exterior angle theorem. And I always misspell theorem, so I have to take my time on it. Theorem. Okay. So we're going to talk about what these words mean. Theorem, it's like a theory. This one is proven, though. Most things in math really are proven. So it is something that has to do with angles. We know that. That's all we've been talking about. And it has to do with specifically exterior angles. And in this case, I'm going to mark the exterior angle for us. It's this one right here. So if you remember from the last one, we had an angle right beside it, and all we had to do was subtract from 180. But this time, I do not have an angle. I don't have an angle right beside it. So that means this is unknown, and the other one is also unknown. So there's 2 ways to approach this. If I were a 7th grader, I would say, okay, this is the inside of a triangle. I can figure the inside of the triangle out. I know that if I add up all of my insides, it should equal 180. So I would add up the 84 and the 48, and I would subtract that from 180. And that would be that x equals 48. And we saw that earlier. We saw that one of our triangles looked like this with the bottom 2 the same. If you remember, that's an isosceles triangle in the bottom when 2 of them match. But you could have also done this a different way, and this is what makes it 8th grade-ish. It's called the exterior angle theorem. So I'm going to get my eraser, and I'm actually going to start over. So some vocabulary that you need to know. We already know that this is our exterior angle. But these 2 angles also have a name in this situation, and these are called our remote angles. And I remember that, guys, by thinking to myself, okay, I know what a remote is. I use it to change the channels on the TV. And it's because I'm far away from the TV. They invented the remote so that people didn't have to walk to their TV anymore to change the channel. So these 2 angles, therefore, are the ones that are far away from the exterior or the outside angle. And guys, the trick is that the 2 remote angles, and we'll write this down, the remote angles, when you add those up, so let's call, we can call this one 84 and the other one 48. When you add those up, it's supposed to equal the exterior angle. So all you have to do is add those two angles up, and then you already know what the outside angle is. You don't even have to worry about this one in green. But as a 7th grader, you don't know that, so you have to figure out this green one first and then move to the outside. So let me work that out for you so you guys can see it. So, and let me erase this over on the side. So if I take my two, what we call remote angles, and I add them up, I get 132. And that's exactly what this equals. It's 132. So I don't have to worry about doing anything else as long as I know the two remote angles. And you can see that's what we got this to be on the other one. It was 132 degrees. So just a piece of extraness that already adds to what you already knew from 5th, 6th, and 7th grade triangles. We are actually going to stop with that one. Sorry for the craziness. We're going to stop with this one. Make sure that you've circled, starred, highlighted anything that you didn't understand from this video lesson, and come prepared in our Zoom to ask some questions. See you guys soon.